Physicists say that the universe had its starting point in an occasion known as the Big Bang, roughly 13.7 billion years ago. This event marks the start of all that we know in the universe, a fantastic explosion that led to all matter, energy, and reality itself. The theory of how things came to be has long been the prevailing scientific explanation for the beginning and evolution of the universe, depicting a moment where the universe rapidly expanded from a hot, dense state into the vast cosmos we observe today. Yet, while this theory offers a framework for understanding the universe's early development, it leaves many questions unanswered. One of the most intriguing inquiries is what triggered this titanic explosion. If the Big Bang was the beginning of everything, what caused it, and why did it happen? These are questions that have energized the interest of scientists for many years, provoking serious review, discussion, and observation in the quest to comprehend the origins of our universe. Over time, researchers have continued to investigate both the science and history of our universe. The Big Bang has been the most prevalent explanation for all that we see, from the distribution of galaxies to the cosmic microwave background radiation. The faint glow of the Big Bang itself has been studied extensively over the years, with countless researchers around the globe dedicating their careers to uncovering the mysteries of the universe. The data gathered from these investigations has consistently supported the theory of the universe's origin as the main model for its formation. According to the hypothesis, a mysterious force, known as dark energy, plays a crucial role in the continued expansion of the universe. Dark energy, which is believed to be far more abundant than the energy found within galaxies, acts as an anti-gravitational force, causing the universe to expand at an accelerating rate, opposing the forces that should theoretically pull everything back together. The field of cosmology has evolved significantly over time as technology advances, and we develop new tools for observation and experimentation. Our understanding of the universe continues to change. Historically, concepts we once accepted as absolute truths have been proven to be inadequate or even completely wrong as new evidence emerges. A prominent figure in modern theoretical physics, Michio Kaku, has pointed out that even the theory of the Big Bang, long thought to be the foundation of cosmology, is now facing challenges. Recent observations made by the James Webb Space Telescope have ignited considerable debate among researchers. The telescope has identified 750 new galaxies that appear to be dramatically different from what was previously expected based on past models. These unforeseen discoveries are driving scientists to reevaluate established theories and explore further into the secrets of the universe. As these revelations come to light, they offer the potential to reshape our understanding of the universe. The James Webb Space Telescope, with its cutting-edge technology, is impacting the way we view the universe. The discoveries it has made so far have pushed the boundaries of our knowledge, particularly regarding the formation and evolution of galaxies. The telescope has captured images of many galaxies that defy past assumptions, leading to a new perspective on the universe's development. These discoveries are exciting not only for what they reveal, but also because they challenge long-held beliefs about the Big Bang. For those passionate about staying informed about the latest developments in astronomy and cosmology, the images and data coming from the James Webb Space Telescope offer a captivating glimpse into the farthest reaches of space. The newfound galaxies, with their surprising structures and astonishing numbers, are prompting researchers to revisit their theories and explore new possibilities regarding the universe's origins. The James Webb Space Telescope has delivered some of the most stunning images of galaxies ever captured in a single frame. One can see many galaxies clustered together, their beauty and vastness astonishing. For the average person, these images are a source of wonder and amazement, offering a brief look into the enormity of the universe. However, for scientists and researchers, these images are not just beautiful, they are also profoundly puzzling. The galaxies captured by the telescope are vastly different from what researchers had anticipated based on the Big Bang model. They appear smaller, more compact, and even older, raising questions about the accuracy of existing cosmological theories. These surprising observations are creating waves of concern within the scientific community, with some researchers even using the term panic to describe the responses to these new discoveries. The discrepancies between what was generally expected and what has been observed are prompting scientists to rethink the fundamental assumptions of the theory of how things came to be. For decades, the theory of the Big Bang has served as the primary explanation for the origins of the universe. According to this hypothesis, roughly 13.7 billion years ago, the universe began as a singular, extremely hot, dense point that rapidly expanded in what is commonly referred to as the Big Bang. This explosive event set into motion the development of the universe, ultimately leading to the formation of galaxies, stars, and planets, including our own. However, the new images captured by the James Webb Space Telescope have cast doubt on this long-accepted narrative. These images challenge the established story of the universe's inception and have opened the door to further possibilities regarding how the universe came to be. The galaxies revealed in these images appear too small, smooth, old, and diverse to fit within the framework of the theory of the Big Bang, suggesting that the true story of the universe's beginnings may be far more complex than previously thought. One of the most striking aspects of the galaxies seen by the James Webb Space Telescope is their size. These galaxies are several times smaller than those captured by the Hubble Space Telescope, which directly contradicts the predictions of the Big Bang theory. According to this theory, as the universe expands, objects within it should appear larger as the distance between them increases. However, the galaxies observed by the James Webb Telescope are not behaving as expected. They are smaller and more compact, defying the standard model of cosmic expansion. Moreover, the smoothness of these galaxies is a surprising and perplexing feature. The theory of the universe's origin predicts that galaxies should display a high level of irregularity in their structures, with noticeable variations due to the turbulent processes of their formation and evolution. Instead, these new galaxies are remarkably smooth, with far less complexity than researchers would anticipate for galaxies of their age. This smoothness challenges the timeline of galaxy formation and suggests that something about the standard model may need to be revised. At the beginning of the universe, all matter, energy, and the building blocks of the universe were compacted into a singular point of incredible density, known as a singularity. This singularity represents the starting point of everything, where the laws of physics as we understand them break down. In this state, matter and energy were so densely packed that their behavior becomes difficult to describe using conventional physics. The concept of the singularity is grounded in Albert Einstein's theory of general relativity, which explains how gravity operates on massive objects. Within the singularity, the density of matter reached an infinitely high value, creating conditions that we cannot fully comprehend or replicate with our current understanding of science. The temperature at this time was so extreme that it exceeds anything detectable in the universe today. It is within the singularity that the seeds of the universe were planted, with all the mass and energy required to create everything we see around us today. After the initial singularity, the universe began to expand and explode, undergoing a rapid process that stretched the fabric of space itself. This expansion, known as cosmic inflation, occurred at an unprecedented rate, far faster than the speed of light. During this phase, the universe expanded dramatically, smoothing out any irregularities and laying the groundwork for the large-scale structures that would later form, such as galaxies and stars. Cosmic inflation played a pivotal role in shaping the universe as we know it today, helping to homogenize the distribution of matter and energy, ensuring that the universe would be relatively uniform on a large scale. As the universe continued to grow, the rate of expansion gradually slowed, allowing for the formation of more complex structures. Researchers have been able to observe the effects of this ongoing expansion through phenomena like the redshift of light from distant galaxies, which demonstrates how the universe continues to expand and evolve over time. During the universe's development, all matter was compressed into a tiny volume, creating conditions that would have made it impossible for stable matter to exist in its normal form. As the universe expanded and cooled, however, these extreme conditions began to change, allowing particles like protons, neutrons, and electrons to form. These particles interacted with the surrounding light and energy, ultimately leading to the formation of matter as we understand it. This process, known as nucleosynthesis, occurred during the first few moments after the Big Bang and played a vital role in the creation of the elements that make up our universe. Interestingly, while researchers expected to see chaotic and disrupted galaxies due to numerous collisions during this early period, the images captured by the James Webb Space Telescope tell a different story. Instead of turbulent galaxies, the telescope has revealed a more tranquil scene rather than violent universes. The telescope has uncovered a more peaceful scene. The worlds noticed are shockingly uniform and seem to miss the mark on confusion that researchers expected in light of the early states of the universe. This brings up significant issues about the cycles that molded these worlds and the principal suppositions of cosmological models. The surprising perfection and little size of these cosmic systems recommend that the development of designs in the universe might have followed an unexpected way in comparison to recently thought. These discoveries infer that the early universe could have been more steady than the common hypotheses propose, prompting another comprehension of how systems structure and create. As scientists dive further into the ramifications of these revelations, they should rethink the timetable of enormous development. The information from the James Webb Space Telescope might prompt modifications in our models of cosmic system development, possibly requiring a reconsidering of the job of dull matter and dim energy in forming the universe. Additionally, the ramifications stretch out past the development of cosmic systems. They address the basic inquiries of cosmology. What occurred during the earliest minutes after the enormous detonation? How did the universe advance to its present status? The novel perceptions challenge researchers to refine their models and investigate elective speculations that could more readily represent the proof introduced by the telescope. Considering these disclosures, cosmologists are empowered to lead further perceptions and reenactments. They are exploring the likelihood that different states of being or cycles might have been impacting everything during the universe's outset. The James Webb Space Telescope has opened another outskirts in galactic exploration, pushing the limits of what we are familiar the universe. The investigation of these universes is only the start. As additional information is gathered, researchers desire to acquire bits of knowledge into the idea of dull matter and dim energy and how they impact the development of the universe. Each new disclosure can possibly reshape our figuring out, prompting a more strong image of the universe's set of experiences. Eventually, the discoveries from the James Webb Space Telescope highlight the unique idea of logical request. As we reveal new data, we should stay adaptable in our reasoning, prepared to adjust our speculations considering new proof. The universe keeps on astonishing us, uncovering its mysteries each perception in turn. As we look forward, the fervor encompassing these revelations fills the craving for proceeded with investigation. The universe, with every one of its intricacies and marvels, welcomes us to address, learn, and find more about its beginnings and advancement. The excursion of understanding our universe is nowhere near finished. It is simply starting.